This presentation is about images. Images are very important to the internet. Most of the images that you are familiar with are so-called raster graphics. Photos taken with your camera or that you find on the internet are usually of this kind. Some common raster graphic formats are JPEG, GIF, PNG, TIFF, BMP, and so on. The way raster graphics work is that they store image information using color values for each little piece of the image. So the raster graphic divides the picture into very small squares or pixels, and then keeps a number that tells us which color we should make that pixel. Raster graphics are also known as pixel maps or bitmaps. One problem with raster graphics is that they have a size. When we want to make them big, when we want to change the size, this can become a problem. So if we want to have a small size and we want to make it bigger, there's not enough information, and when we try to make the picture larger, it becomes blurry. So you can see that in this example that I've shown you, this small picture. When we try to make it bigger, all the edges become unsharp and even show strange colors. If we look inside a raster graphic, we can see that the inside is simply not comprehensible to humans. Basically, the file is just completely full of only nothing but numbers. The file will need a computer to understand this image and display it properly. However, there's another way to create and store images on a computer. Instead of storing information for each dot of the image, we can give instructions on how to draw what we want. Then the computer will be able to recreate the image. So the way to imagine this is look at this picture of a little bird here. So imagine we can look at the eye here and we can see that the eye is basically a circle. Inside it is the pupil, which is another circle, and we can even use another circle here to make the eye more realistic. Or the beak is actually a triangle. The body and the wing are formed by nice smooth curves. So we can use mathematical formulas to draw these pictures. If you look inside a vector graphic file, you'll see that it is much more comprehensible than the raster graphic. So this here is the same little bird. If we look inside, you can see there's all kinds of words, even things like beak or wing and so on can be inside. And even the parts where the drawing is are quite understandable. They still have words like circle or path, and here they have nice numbers, and it's easy to understand this, or at least easier to understand it. If the picture is complicated, the best way to draw the picture will be with using specialized software that creates this kind of file for you. Some typical examples of vector graphic software are Adobe Illustrator or Inkscape. Inkscape is a free program. Anybody can download it. It costs nothing. It's very convenient to use, so I strongly recommend it. In this class, we will learn how to draw or how to make some simple vector graphics using just a text editor. So we don't even need a specialized software to draw such a thing. So now I'll explain about one type of vector graphic that anyone is free to use. This is called SVG. What is SVG? SVG stands for Scalable Vector Graphic. What's convenient about SVG is we can add it directly to any HTML file. So HTML5, which we have learned in this class, understands SVG. And most browsers can show you such pictures right away. Another advantage of SVG is that it can be styled using CSS. So we can make it look nice using the CSS method that we learned. SVG works quite similar in a way to HTML that we learned in this class. So it's written using tags. The basic tag is called SVG, and it's a paired tag. So we open it and close it. Inside, we will give instructions for how to draw our vector graphic. The SVG base tag that we have here is going to need several attributes. The first attribute is called XMLNS. This attribute determines the namespace. I will not try to explain this. The easiest way to use this is to simply copy the XMLNS specification, the line for this attribute that I gave you in the instructions. Aside from this, we'll also need width and height. These two things will determine how large our image is. Finally, a third thing that we can use if we want and make our drawing more convenient is the view box. View box will set the coordinate system that we're going to use to draw. So, this is how it works. SVG uses a coordinate system for drawing. You may have learned how to use coordinate systems in high school or even junior high school. Basically, we imagine the world described by pairs of numbers. The pairs of numbers go in one set of numbers go in one direction, in the horizontal direction. This is called the x-axis. The other set of numbers goes in the vertical direction. This is called the y-axis. So if we want to pick any particular number, say the corner of this star here, we might notice that it's at basically the point which is about 211 on the x-axis and 152 on the y-axis. 152 on the y-axis. So we would describe this point here as being 215, 152. If you have learned this before in high school or somewhere else, you might usually have seen the numbers go up in this direction and the ones going down being negative numbers. On the computer, it's more convenient to use positive numbers in the downward direction. Let's look at some basic elements. What are the basic elements that SVG can draw? First, we have the circle. A circle can be described with a point for the midpoint. We'll call the CX and CY. And a radius, R. We could draw a line. For a line, we indicate one first point, which will give it x1, y1, and the second point, x2, y2. Another convenient common used shape is a rectangle. SVG uses the shortened name rect for rectangles. Rectangles are described by giving the upper leftmost point as x and y, and then saying how high the height and the width. Rectangles described this way will always be square, will always be straight on our coordinate system. If we want one that's slanted, we'll have to do something else. Finally, another convenient shape is the ellipse. It's similar to a circle, but we have two radiuses that we can specify independently and give an oval shape, either this way or maybe like this way, right? Simple shapes will only get us so far. SVG has another method that allows us to draw just about anything we want. This is called the path. To understand paths, imagine the way your pen moves while drawing. You hold your pen, you move it to a point, you set the pen down, you draw a line to the next point. From there, maybe to even another point, maybe making a curve, and so on. We can describe this path in this way using a simple system of letters and pairs of numbers. So the path will have an attribute, a so-called D attribute, which will describe this path that we drew, the way of drawing our path. Inside the attribute, the value for the attribute will be made up out of string of such pairs of letters and pairs of suitable coordinates. So M 200 to 150 will mean move the pen to point 200 and 150. Then L 2586 will mean draw a line to the point 2586. And so on. You can continue as long as you want. Drawing shapes is fine, but we also want them to look nice. We'll need to add some color. There's an important thing about color is that we need to distinguish two things. One is the color that we want to use to fill the shape, and the other is the color that we'll want to use to mark the line that defines the shape. This is called the stroke. The first color is called the fill, and the second color is called the stroke. For the drawing line that defines the shape, it could also say how thick we want it to be, whether it should be just a very thin line, almost invisible, or a very thick one, or even, for that matter, none at all. So we can set this with stroke width, which will set the thickness of that stroke. Another thing that will help us make complicated drawings simpler is our transforms. Transforms allow us to change the position, orientation, and size of any part of our drawing. They will be specified using an attribute called transform. Inside the transform, we will have three basic ways of transforming. They're called translate, rotate, and scale. Here's what they look like. Translate is what we use to move an object, an image shape from one place to the next. So from here, so we can move the star from here to here. Rotate will turn our shape around a fixed point. We can specify how much we want to turn. Scale will make our shape bigger. It will start here, so it starts here and moves it. Scale can be specified by a factor. So 2 for twice as big. Finally, one more important tool to simplify drawing complex things is the clip path. A clip path allows us to cut off parts that we don't want or need. One way to think of this is using one shape as a window to look at another part. then SVG will only draw the part that we can see through that window. This can make drawing of very complicated shapes of what otherwise would be very complicated shapes a lot easier.